Today I'll talk about a very interesting paper that appeared in February 2024 called Self-Discover Large Language Models Self-Composed Reasoning Structures. Um, you can see all the authors listed here. And let me remind you that all the talks that I make the PowerPoint slides available to you. I'll share the information in the last slide of my presentation. So this is a general framework to self-discover task intrinsic reasoning structures. What it means is that we give a list of reasoning modules or atomic reasoning modules such as step by step, break the problem into smaller problem, critical thinking, and so on and so forth. And the LLM decides which one of these to pick. From performance point of view, it shows up to 32% improvement over other reasoning method, for example, chain of thought. It's also quite efficient, although it needs few more calls to LLM compared to chain of thought. It has larger number of tokens, but it's still very efficient for what it does. And it's very general. It's applicable across different families of models. So the inspiration for self-discover come from how humans solve the problem, how humans devise a reasoning methodology to tackle a problem. So given a problem, we know what skills we have and we try to break down the problem into the skills that we have or the reasoning, the understanding of the world that we have. Okay. It exactly does the same. It has a repository of atomic reasoning modules. It has the task and the language model itself discover what reasoning modules to apply, and it adapt them to the problem. And then in stage 2, it basically use that reasoning structure to solve the problem, again using a language model. I'll go into much more details in the coming slides. Let me compare it first with the existing methods. One of the big limitation of the existing methods is that each method serves as a specific reasoning module. So it does one type of reasoning. For example, zero-shot chain of thought does step-by-step reasoning. Okay, and there are some methods that do critical thinking. So they basically show one kind of reasoning compared to what self-discover do, which selects what kind of reasoning it has to perform in order to solve the task efficiently. So I'll just show you what least to most prompting is and what chain of thought prompting is with self-consistency, so that you understand what other methods exist that can be compared to self-discover. So this is chain of thought with self-consistency. Just to remind you, chain of thought is simple prompting, give few examples of step-by-step reasoning to solve the problem at hand, or just adding step-by-step, think step-by-step at the end of the prompt in case of zero-shot chain of thought. Okay. So chain of thought gives the intermediate steps, but if we produce multiple chain of thought outputs using a single model or multiple models, and we pick the one where most of the outputs agree. Okay, for example, in this case the answer is 18. There are 2 votes for that. Answer is 26. There is 1 vote. We pick the one with majority voting, and that's chain of thought with self-consistency. Okay. So this is a very good approach, but as you can see, you have to call the LLM multiple times to generate output. There is another prompting method, existing prompting method called least to most prompting. In least to most prompting, what we do is we decompose the question into sub questions or sub problems, and then we solve those problems, and after that we try to find the final answer based on that. For example, if you look at the upper right corner in the question, you can use the large language models, and it comes up with the solution that how many times can she slide before it closes, and it says we need to solve how long does each trip takes. Okay, so it needs to solve the sub problem before it can solve the full question. So that's what it does. It's stage 2. It solves the subproblem and then it puts the output of the subproblem and then it asks to solve the main question at hand. And it does better job than um, simple chain of thought prompting. On some data sets, like SCAN, which is a compositional generalization data set, it shows amazing performance. Okay, coming back to self-discover. So self-discover, if you see like direct prompting, what we have is task and we directly go to answer. In case of chain of thought reasoning, we have a task, we ask the model to give us some rationale and then we go to the answer. Self-discover is different. We have the task, we ask it to first find the reasoning structure or find the reasoning structure from the given atomic reasoning modules that we listed, and from the structured applying structured reasoning on top of that, we reach the answer. And this is amazing. They show the performance on 25 different tasks, which include many tasks in big bench hard problem benchmark, agent reasoning, T4D benchmark, and math benchmark. So out of 25, when we compare to direct prompting, it performs well on 23 out of 25. And when we compare with chain of thought, simple chain of thought, zero shot prompting, it performs better on 21 out of 25 tasks, which is a very good performance. Showing in one level more depth, like the stage 1 has 3 different steps. The first step is select. Basically select all the modules, all the reasoning modules. I have used this term reasoning module many times. I'll show you very soon what it means. So let's suppose there are many reasoning module like step-by-step breakdown, propose, verify, and we ask the language model to select some of the reasoning module that apply to the current task at hand. Then we adapt. This is a very important step. We adapt it to the question that we have. For example, in this case, it is adapted to step-by-step analyze each item and so on and so forth. And the next is implement, where it converts the adapted modules into kind of executable reasoning structures. Okay, and then the last stage comes in that executes this, again using large language model. So here is a list of 39 reasoning modules. Let me say that one of the strengths of this approach is that these reasoning modules are customizable. You can add your own, you can delete whatever you want to do. For example, if you look at 38, it's let's think step by step. So chain of thought, step by step is a part of this. Then there are like number 10, critical thinking. Number 9, how can I break down this problem into smaller, more manageable parts. So, and this is adopted from the existing work. You can see the reference in the original paper. So the prompts, how the prompts are designed is we say, for example, select several reasoning modules that are crucial to utilize in order to solve. Then we give all the reasoning modules. We give few examples of the task that we want to solve. We can give one example also if you want. And then we give the prompt again. So the instruction is given at the beginning and at the end of the prompt. Then in the second step, we ask it to adapt, rephrase and specify each reasoning module so that it better helps solve the task, given task. Okay, again we give everything that was done before, like the outcome of the last step, selected modules, and then we give the tasks, examples again, and then the prompt again. And in implement, we can show it a demonstration. It works even if we don't show, by the way. We can show it an example and we say convert it into step-by-step reasoning plan, and this plan is then executed in the last stage. So here is an implementation. If you want to see, it's really simple because it's just prompting. The main contribution, I believe, is coming up with a very cool set of 39 reasoning modules and putting everything together. For example, here the task is Lisa has 10 apples. She gives 3 apples to her friend and buys 5 more apples from the store. How many apples does Lisa have? So I'm not showing you all the LLM calling and everything here, just making it very simple, taken from this code. You can see like the first step is select reasoning modules. I give the task example and I give the list of 39 reasoning modules. It select few reasoning modules. Okay. And then in the next step, I give it the selected modules and I give the task example again. Okay. And it gives me the adapted modules and so on and so forth. I go to the next step. Okay. This is how it will look like, the output. You can see that in stage 1 select, it selected two reasoning modules, number 9 and number 10, critical thinking and how can I break down the problem into smaller, more manageable parts. Then in the adapt, you can see that it basically takes those selected reasoning modules and it adapts them to the problem. For example, it says calculate how many apples Lisa has after giving 3 to her friend, calculate how many apples Lisa has after buying 5 more apples, and so on and so forth. Then stage 1 reasoning structure, in the middle, it break down the problem into reasoning, like executable reasoning kind of components. Okay. So here you can see it clearly says that Lisa starts with 10 apples, she gives away 3, subtract the number of apples given away from the initial number of the apples. So this is kind of executable for an LLM. And then so on and so forth. You can read all of it. And in the final stage, it basically executes it. It finds like 10 minus 3 is equal to 7 and so on and so forth. And it comes up with the final answer, which is given at the end of the slide. A very clear example to show the benefit of this. For example, here the question is this SVG path element something something. Is it a circle, heptagon, hexagon, or many shapes? Okay. So let's think step by step chain of thought. What it does is that it finds it to be a kite. Okay, it gives a wrong reasoning. Then we say plan and solve. This is another method. It again comes up with the answer which is wrong, kite, and it makes wrong reason also. The instruction make 4 lines in total, it's not a closed path, and so on and so forth. On the other hand, self-discover reasoning structures basically find out with 7 distinct points all connected in a closed path the shape formed a heptagon. So it comes up with the right answer, which is a heptagon. Here they show the performance of the self-discover on 4 different categories inside Big Bench Hard benchmark. Okay, multilingual, algorithmic, NLU, world knowledge. We can clearly see that the problem where world knowledge is required, it shows up to 20% improvement when compared to chain of thought or direct prompting, and we definitely see significant improvement in other categories also. Here you can see on all big bench hard tasks, there is human average, human max, GPT-4 direct performance means no complex prompting, simple prompting, GPT-4 with chain of thought, GPT-4 with self-discover. So you can see in most of the problems, you can see an increase when we use self-discover compared to other prompting techniques or direct prompting. Same goes for Palm model, Palm 2L. We see very similar behavior. Here we see the number of inference calls that this technique self-discover needs to make as compared to other techniques. So the star represents self-discover. So we can see that it needs to call 1, 2, 3, 4 calls to the large language models compared to some other method. For example, chain of thought, zero shot needs to make 2 calls. Chain of thought with few shots, need to make 1 call. However, for example, chain of thought with self consistency, if you're using 10 different outcomes, 10 different models, then you need to make 10 calls. If you do majority voting over all reward all reasoning modules, you need to make 40 calls here, or 39 calls. Same goes for best of each reasoning module. You need to make 39 calls. So it is quite efficient, although the number of tokens is quite large here that we need to input, because we need to give the all 39 reasoning as an input to the LLM. And the asterisk on top of best of each reasoning module means that you need to have goal labels in order to find the best of each, otherwise there is no way for us to tell. It's available on this Llama index also. So if you want to see Llama index have a pack for self-discover, you can see how it's implemented. The output of the previous, like select module, goes to the next step, adapt prompt, and so on and so forth. It's very easy to follow. You can go to this link to check that. Thank you. And there are many ways to connect with me. As I said, you can download the PPTX PowerPoint version of these slides from my GitHub repository. Just go to this link on GitHub website and go to talks, and you'll see this talk, slide for this talks, and many other talks that I have done before. Thank you.